Assalamu alaikum. I hope you are fine and doing well in your physical chemistry classes. Today we are going to take a brief review of chemical kinetics. We will discuss important topic with respect to chemical kinetics. First, let's check what chemical kinetic stands for, or which area is covered in chemical kinetic. Basically, when we study chemical kinetic, we refer to the study in which we focus on rate of chemical reaction, factor influencing rate of a chemical reaction. We also discuss mechanism, catalyst, kinetics, etc. All these different areas of study in chemical kinetics. So whenever we start with chemical kinetic, we usually begin with the rate of a chemical reaction. From rate we mean a change in concentration per unit time. For example, when we are executing a particular reaction in our laboratory, then we mix up different ingredients required for a chemical reaction as a reactant, and then set on a reaction and wait for some time, and then ultimately we get a product. So the rate is basically the transformation of a reactant into product. This rate is calculated or monitored in unit time, or it is calculated or measured with respect to time. We check out the rate that how much of reactant are transforming into product per unit time. So basically rate of reaction is the change in concentration of reactant, especially change in concentration of reactant or product divided by a time. So here we have a unit as well. This is the rate, which is equal to concentration per unit time. So concentration is expressed in mole per dm3. For second we use the unit second. So as a whole, the unit for it will be mole per dm3 second inverse. Here we have shown a simple reaction in which silver nitrate react with sodium chloride in aqueous solution. It gives rise to formation of a white PPT and sodium nitrate. The reaction is spontaneous. So at the start, when there is no formation of product, all are reactant, the rate will be fast. Why? Because there are a greater concentration of both reactants such as silver nitrate and sodium chloride, but with the passage of time, when a greater part of reactant consumed, the rate will decline. So we can say that the rate of any chemical reaction is faster at the beginning when there are large number of molecules on the reactant site which are available for reaction, but soon with the passage of time, when these reactant molecules decline in concentration, then the rate also drop. In other words, rate is directly proportional to concentration of a reactant or a product. Naturally, the rate of reaction can either be slow or it can be very fast. For slow reaction, we have an example of rusting of iron, which is a very slow reaction. It takes years for the reaction to complete, or a metal to be corroded or rusted. Or even we have also an example of weathering of rock, which is also a very slow reaction, for which the rate of a chemical reaction is quite slow. So these are the reaction in which the rate of a reaction is very slow. But exothermic reaction are concerned, they are very fast. And they just for example, take an example of different biochemical processes like the formation of glucose or ATP and ADP transformation. Similarly, photosynthesis or Krebs cycle, these are all very fast reaction for which the rate of a chemical reaction is very high. As far as we study rates, so we can have average rate. Basically, average rate is the rate of a chemical reaction between two specific time interval. And as far as the instantaneous rate is concerned, it is a rate of a chemical reaction at any instant during the course of a chemical reaction. For example, when a chemical reaction is going to take place, so at any stage when we monitor the rate of transformation of reactant into product, that particular moment is known as instantaneous rate. Here we have graphically shown how the rate of a chemical reaction takes place. Just look at this graph. We have two species such as A and B. Here we have shown that A is transforming into B. So as the reaction set on, the concentration of A will decrease and the concentration of B will increase. Why? Because B reflects a product, because the product will increase in concentration with the passage of time, where all the reactant will transform into a product. So this is simple graphical representation for a chemical reaction. So when we express the rate of a chemical reaction, just take out again this example for A transforming to B. We have minus delta A or delta T. The minus symbol reflects a decreasing concentration. Why? Because when the reaction set, the concentration of A will decrease. But as far as B is concerned, we take it positive. Why? Because its concentration increase with the passage of time. Now when we write a chemical reaction for which the rate is directly proportional to concentration of a reactant, basically in rate law we usually study here these all are information which are given about rate of reaction. I am talking about rate law. Here are some few examples. Okay, here is the rate law. Basically, rate law tells us that the concentration or the rate of a chemical reaction is directly proportional to the concentration of reactant. We have replaced the proportionality with a constant K, which is known as rate constant. So the rate constant is derived or obtained from a rate law. Basically, a rate law tells us about the rate of a chemical reaction which is dependent upon the concentration of reactants. So here we have a rate constant which means that rate constant is a specific rate constant or specific rate constant is the rate of reaction when the concentration is unity. For example, when these terms get unity, then the rate of reaction will be equal to rate constant. In other words, rate constant is equal to the rate of a chemical reaction or divided by the concentration of time. So this is simple about rate constant, which is obtained from a rate law. Next, we are moving towards order of a reaction. Order of reaction basically tell us about a concentration of reactants. We are not talking about order with respect to product, because product doesn't matter in determining the order of a reaction. But whenever we talk of order, basically we refer to concentration, or in other words, the role of concentration of reactant. In other words, we can say that when a reaction is taking place between two or more than two reactants, So if a particular reactant is double in its concentration, then we check out whether the rate of reaction also get double or not. If the rate of reaction double by doubling the concentration of any species on the reactant site, then we can say that the order for that particular reactant will be dependent upon the concentration. So when we talk of order of a chemical reaction, order is basically the concentration which increase the rate of reaction. There can be a zero order reaction are independent of order. We can have a first order reaction which the concentration is dependent on only one species, and we have a second order reaction, we have a third order reaction. So in rate law, basically we add up coefficient here in this equation, where small a and small b, these are coefficients, like 1 or 2 or 3, any coefficient can be there. These are coefficients in rate law. Just here check out in this rate law, we have written the coefficient in x and y, where x and y are coefficients. These are coefficients. So when we sum these coefficients, these tell us about a rate of overall reaction. This rate law tell us with respect to order that with respect to concentration of A, the order is X. With respect to concentration of B, the order is Y. For a reaction as a whole, the order will be the summation of X plus Y. So when we have value of X is equal to 1, Y is equal to 1, both will be added and it will give us a 2, which means that this reaction is of second ordered. Here we have briefly defined what is the order of a chemical reaction. Just focus on this statement. For above equation, A and B are the order of individual reactant. Their sum is the order of an overall reaction. In other words, the number of reacting molecules whose concentration alters as a result of a chemical change is called order of reaction, or we can also define it as the sum of all the exponents to which the concentration in rate equation are raised is said to be order of a chemical reaction. We shouldn't confuse small k with a big or capital K. Capital K reflect equilibrium constant, where small k tell us about an equilibrium reaction constant. Now let's move towards next segment. As far as the rate of a chemical reaction is concerned, it is experimentally determined quantity. We cannot tell the rate of a reaction just by looking at the chemical reactions written on the paper, but all rates are determined experimentally. We can use a spectrophotometer in our laboratory in order to monitor the rate of a chemical reaction, in which it gives us information that how much the reactant transform into product. As far as the factors are concerned, there are many factors which are important while we are discussing chemical kinetics. So we will briefly discuss these factors, that what are those factors which influence the rate of a chemical reaction. So these factors can be concentration, temperature and pressure, catalyst, light, pH, medium of reaction. As far as concentration is concerned, it's an important factor. It just previously from the rate law, we have stated that the rate of reaction is directly proportional to the concentration of a reactant. Greater the concentration of reactor, higher will be the rate of reaction. As far as temperature is concerned, temperature also play an important role because it accelerates the rate of collision. When there is a greater number of collision among reactant molecule, the rate will be higher because the individual molecule will have a high chance to react with each other. And as far as the pressure is concerned, pressure basically depends upon whether we are discussing a gaseous reactants, because reaction can either be in gaseous phases or in liquid phases. So for gaseous phases, the pressure parameter is very important. As far as light is concerned, or pH as medium of the reaction, all these are important aspects. Here we have given a reaction which can be instantaneous, it can be moderate, and it can be slow. A chemical reaction can be instantaneous, moderate, or slow depending upon the rate of a chemical reaction. If the rate of a chemical reaction is slow, such as nitrogen fixation or rusting of iron, these are very slow reaction and it requires a lot of time to take place. There are some moderate reaction for which the rate of a chemical reaction is moderate, and there are instantaneous reaction as well, such as glycolysis and Krebs cycle. For these reaction, biochemical reaction, the rate of reaction is very fast. Here we have given the rate law again, which we have studied previously, that what is rate law. Rate law, as we have stated for a reaction, for example, just A is transforming into B, the rate of reaction will be directly proportional to the concentration of A. We have replaced the proportionality with a constant small k, that is a rate constant. Rate constant, this equation, the rate law equation can be rearranged to this equation, for which we can use our earlier unit. So the reaction or the rate constant unit will be second inverse for first order reaction. It is important to note that the unit for rate constant depend upon order of a chemical reaction. Here we have shown a brief difference between a rate of a chemical reaction and rate constant. It is important to note that the rate constant is a proportionality constant, whereas the rate of a chemical reaction, it changes with time and reactant concentration. The unit for rate constant is second inverse, and as far as rate of reaction is, that is mole dm3 inverse minus cube and second inverse. Rate constant is independent upon the concentration. In other words, we can say that the rate constant doesn't depend upon the concentration of a reactant, but as far as the rate of reaction, it depends upon the concentration of a reactant. Under given set of conditions, the rate constant is same, but it changes as soon as the reaction progresses. Here we have given different units for rate constant. For zero order, how we can obtain the unit for rate constant? We can use this equation. This is an equation for which rate for second order reaction. Rearrange this equation to k is equal to mole dm3 second inverse. Also this is the numerator is rate and denominator will be the concentration. It will double. Why? Because it is second order reaction for which the unit. So as a whole, this is the unit for a zero order reaction. This is for first, this is for second, and this is for third. I hope you have gotten a good insight of chemical kinetics. In today's lecture, we will discuss in our next lecture about the order, how different factor influence order of a chemical reaction, how order of reaction is derived, what are important mathematical equation with respect to order of a chemical reaction. Thank you very much for watching the video.